The other example of greedy approach is minimum spanning tree. A minimum spanning tree, several of a minimum spanning tree graph are existed, but if every edge has a unique weight, then there is a unique minimum spanning tree graph. Suppose that if a graph G equal to V comma E, graph G is the set of vertices and edges, be an undirected graph. Then T is a minimum spanning tree of G. T minimum spanning tree होगा आप G का ग्राफ का if T is the proper subset of E. यानी T जो है कि E की प्रॉपर सबसेट मतलब E की कुछ एजेस यहाँ पे यूज की जा रही हैं स्पैनिंग ट्री इज एन एसाइक्लिक सबसेट और इस तरह से यूज की जा रही हैं एज ए एसाइक्लिक सबसेट दैट कनेक्ट ऑल द वर्टेक्स एंड whose total weight WT equal to summation of WUB is minimized. मिनिमम से मिनिमम वेट आपका आ रहा हो, कोई साइकिल नहीं बन रहा हो, दिस इज ए minimum spanning tree graph. Now minimum spanning tree graph solved with the help of two algorithm, first Krushkal algorithm and Prim's algorithm. First we discuss Krushkal minimum spanning tree algorithm. Suppose that a graph is given, undirected graph is given, and each edge contain a unique weight या path value. So according this algorithm, first we arrange these edges in a increasing order, and first we select minimum path value of edge if it does not cause a cycle. If cause cycle, then rejected those edges like that. First select minimum time, minimum weight S2 and connected these vertices. Next minimum weight is 3 and no cycle is created. Next is equal to 4, no cycle is created. Next is 5, no cycle is created. Next is 6, no cycle is created. Next is 7, no cycle is created. Next is 8, no cycle created. Next is minimum 9, but for selecting a 9, then cycle is created, so 9 is not selected. Next 10, for selecting 10, then cycle is generated, so 10 is rejected. Next is 11, after selecting the 11, then cycle is created, so 11 is rejected. Next is 13. 13, for selecting 13, no cycle generated, then we can select the value of 13. Next is 14. अगर 14 लेते हैं, then cycle is created, so 14 नहीं लेंगे. Next is 15, no cycle generated. So this is the minimum spanning tree graph of Krushkal algorithm. Why Krushkal is a greedy algorithm? How explain? Algorithm manages a set of edges. These edges are a subset of some MST. At each iteration, choose an edge so that minimum MST subset property remains true. Sub-problem left is to do the same with the remaining edges. Always try to add cheapest available edge that the value that will not violate the tree property. So locally optimal choice. For implementation of Krushkal algorithm, sort as by weight, sort as edges by weight, efficient algorithm known. How to test quickly adding the next edge would cause a cycle. Use disjoint set data structure. Example of Krushkal algorithm, another example of Krushkal algorithm like that. Suppose that graph given है and इस ग्राफ में आपको मिनिमम स्पैनिंग ट्री फाइंड करना है. तो फर्स्ट वी सेलेक्ट द मिनिमम वेट एज like that 1 1 2 given है. First selected this is and next this. Next minimum is 2. selected 2. Next is 3, selected 3. Next another 3, but ये select करने पे आपके पास cycle generate हो जाए, then we cannot select it is as this as, so it is not selected. Next is 5. Next another 5. 7. After 7 selection, then create a cycle, so rejected. Also 8 is not selected because create a cycle. This 8 is selected, so the minimum spanning tree graph is this. Krushkal algorithm like that. If graph given G, comma W with weight, first no as selected is empty for each vertex V in V vertex of graph. To make set V, sort the edge of in non-decreasing order by the weight W. After arranging the edges according to weight, for each edge u comma v in the E taken in non-decreasing order by weight, 2 if find set u not equal to find set v. इस तरह से सेलेक्ट कर रहे हैं, कोई साइकिल जनरेट नहीं हो रहा है, देन वैल्यू एज की उसमें ग्राफ में ऐड होती है. So another example of Kruskal spanning tree like that. Suppose that A, B, C, D, E, F, G, H, I, F, G, H graph given है, each as weight given है. तो first क्या करते हैं, arranging the edges weight in increasing order of cost. So first is AC equal to 1, AB equal to 2, CS equal to 2, B equal to 3, DG equal to 3, CD equal to 5, FG equal to 5, BD equal to 8, is equal to 8. ये हमने सारे एजेस को इंक्रीजिंग ऑर्डर वेट के अकॉर्डिंग सेट कर लिया. नाउ फर्स्ट वी सेलेक्ट द AC minimum weight. AB equal to, select AC equal to minimum weight 1. Next select AB equal to 2. Next select minimum weight CH2. Next select B equal to 3. Next select DG equal to 3, TG equal to 3. Next CD equal to 5, CD equal to 5. Next is FG equal to 5, F and G equal to 5. Good. Next BD equal to 8, B और D 8 not selected because यहाँ पे cycle generate हो जाए. EG equal to 8, E और G not selected because इसको लेने से cycle generate हो जाती है. EF equal to 9, EF से लेने पे cycle generate हो जाती है, cycle closed loop बन जाता. BH equal to 10 not selected and GH equal to 12 is not selected. So total cost of this minimum spanning tree equal to 1 plus 2 equal to, after adding the weight, find the total cost of minimum spanning tree equal to 21. This is the example of greedy approach using the Kruskal algorithm, Kruskal minimum spanning tree algorithm. So time complexity of Kruskal algorithm. First, for selecting total number of vertex order of V. Next, we selected each vertex V comma G equal to E log E, and then make a set, select each edge according to the increasing order of weight, then total time complexity, we go P plus E log V. So we can say time complexity of Krushkal algorithm is E log E or E log. We also define the time complexity as mod V make set on per node, 2 mod E find set 2 per S, mod V minus 1 union of since spanning tree has mod V minus 1 as in it sequence W order of E operation mod V of which are make sets, time for disjoint sets E log V dominated by time of sort the S which is the order of E log E equal to E log V. इसलिए टोटल टाइम कॉम्प्लेक्सिटी वी कैन से ई लॉग वी बिकॉज यहाँ पे सारी वर्टेक्स को चूज करते हुए हमें एजेस को सेलेक्ट करते हैं तो कितनी एज सेलेक्ट हुई लॉग नंबर ऑफ वर्टेक्स की ट्री के अकॉर्डिंग तो टोटल टाइम कॉम्प्लेक्सिटी ई लॉग वी ऑफ उसका